So I've got another one of these Panasonic plasma sets here. This one's supposed to shut down and start flashing codes on the screen. We'll see if this thing runs for any length of time here. Shut that volume off. So this is supposed to shut off with a code. It'll run and it shuts off with 11 flashes. So let's see if it will. So I'm going to let this thing just run for a bit and see whether it actually does shut off. I've got my cheater codes here. These are Panasonic blink codes for all Panasonic TVs. And they read as follows. One blink is your 5-volt sense on your DG board is missing, or STV 5-volt sense. 2 blinks, that's a 15-volt SOS on the D board. 3 blinks is 3.3-volt SOS again on the D board. 4 blinks is a power SOS on the P board. 5 blinks is 5-volt SOS on the D board. 6 blinks, driver SOS, 1 SU or SD or SC boards. So that's an energy recovery circuit. That would be a buffer or a scan drive. So sustain board. 7 blinks is another one for sustain board on either the SU, SD or SS boards. And it says a scan drive or SE floating voltage area. That's grounds usually that cause that. 8 blinks is an SOS for the SS board. SOS3 as they call it for the SS board. 9 blinks is a bad one. That typically means you got a bad panel. 10 blinks is your sub 5 volts SOS or your main 3 volt SOS DG board. Your DTV 9 volt for the tuner SOS and tuner power. 11 blinks, fan, SOS, PB board. 12 blinks, sound SOS on the H board. And 13 blinks is a communication error between the DG board and IC801. So that's another bad one because it could be a broken connection. This one here apparently is doing an 11 blinks, which says it's a problem maybe with one of the fans on it. This is another one of those big plasmas. And this one's not nearly as filthy as the last one I saw. Actually, this one's actually relatively clean inside. But I suspect that maybe one of the fans has got a problem. We're going to monitor this thing for a bit. Basically, how this set works is there's a speed FG sense line on each fan. So if one of the fans were to stop rotating or be rotating too slow, it would send an immediate shutdown command to the TV. I kind of think that might be what's going on this one, but I kind of have to monitor it here until it shuts down. And we'll see whether we have a fan problem or whether we have a voltage problem that's driving the fan. So we'll just monitor it here for a bit and hopefully it will go or act up before it has to run too long, but that's what we're here for. We're going to monitor this thing and just see what happens. This is a beautiful TV. I love the picture on this. This is a fantastic TV. This is, again, one of those really nice ones. This is the same type of set that I had with the ground problems, a previous set. So to get 2 sets the same within a short period of time tells me maybe I might see a few more of these things. But it's got a beautiful picture. Anyway, let's monitor it for a bit and see whether it'll actually shut down. I have a feeling it's the right fan. I'm using the old mechanics trick. putting a screwdriver up against the fan and sticking the other end in my ear, and I can hear what sounds like it could be a bad bearing on the rightmost fan. That's my suspect, is that possibly a fan has gone bad. I wonder if there's a way that I can amplify this for you guys to hear it. I may just have a solution here too. I may just have a solution. I don't know if I can plug a microphone into this camera or not, but I really would like to let you guys hear the sound that I'm hearing. Hopefully this thing will shut down. And I'm kind of watching the fan at the back to see if it slows down too, as I'm monitoring this thing. I'll bring the camera around the back so you guys can see what I'm looking at here. So the set has 3 fans. I suspect it's this one here that's acting up. I'm going to try and get a microphone up to there so that maybe you guys can hear it. Okay, I've got the headset on now, so my audio is probably sounding a little bit different now. Probably sounding better actually with the headset mic on. I'm going to put the headset up against the 3 fans so you guys can hear the noise that I heard when I put a screwdriver up against it. And you'll hear this fan here is making quite a racket. I suspect that this is the fan that's at fault, but listen to the sound that the 3 fans, listen to the distinct sound that they make. So there's fan number 1. Okay, those sound pretty normal. Now listen to this one. I'm sure you heard the difference in the sound. I think we have a bearing that is bad on this one. When I put my finger up against the fan, I can actually feel the bearing wobbling. So I think our fault on this set, and I'll be able to confirm that when the bloody thing shuts down for me, but I think we're going to find that the problem on this set is a bad fan, is what I'm thinking. And as you heard from the sound that it made when I put the microphone up, see the difference? Quite the difference in the sound. So that's what I think. We're just going to have to watch this thing and see whether this fan shuts down. I'm sure if I were to stall out one of these fans, it would go immediately into shutdown, but I want to let the thing run and just see if it's going to kick out on its own. So I'm just getting a shot of the clock there so that we can see how long it's before it shuts down. Gonna shot it's 10 o'clock right now, and I'm gonna shut my video camera off here and just let this thing run for a while, and we'll see how long it goes before it shuts down. Oh, I've noticed the set's shut down. Here's our code. Where is that light? There we go. There's 11 blinks and a pause. According to my clock on my monitor, it took 20 minutes for that thing to shut down, because it's now 21 after 10. Nice burn-in down here. Look at that. You can see the door from my security cameras in the past. So, yeah, 20 minutes it ran, and it finally kicked out. So I'm just gonna, let's just rotate these fans by hand here to see if they're kind of sticking a bit. Get the camera out of the way here. Okay. So if I, yeah, that one feels kind of stiff when I turn it. You see, it's not turning freely. If I look at this other fan here, you see how that one kind of rotates and rocks back a bit. You see that? If I turn it forward, the magnet pulls it back a little bit. And same with this one here. Right? This one here sticks. We have a bearing fault on this fan. I'll get you a close-up of those. Just move the camera a bit around here. So, good fan. Let's see if I can see this better here. Okay, this one's a good fan. You know, watch what happens when I turn the blades. See, they kind of spring back a bit because the bearing is very loose on here. Same with this other one over here. When I turn this one, we go over to the suspect fan over here. Where's this one here? Watch what happens when I turn this one. Right? It doesn't spring back. Interesting. The other one's over here. See? This fan is shot. That's going to be the problem on this. This fan here is bad. So to remove the fan, there's just a couple screws on here. It should be 3 screws. And 1 plug. I think I'm going to lay the TV on its face too. I don't want it falling over. These things are notoriously front heavy. So once the fan is unfastened, it just unplugs. And these would normally be replaced as an entire unit. So now I'm going to remove the fan from the bracket. There's just 1 screw that holds it in place. I can lift out this bracket here. And I should be able to just lift the fan out. Which it comes out just like that. It has these 4 little rubber feet on there. I'm going to have to change the connector that's on the fan, and the reason for that is because the new fan is a PWM fan for a computer, and it comes with a 4-wire connector instead of a 3-wire connector. So basically here's the new fan that I've got. It's the same size. And I'm just going to replace the fan. I'm going to make sure I got the right airflow too. So the airflow it's going that way. So I have to make sure that I put the new fan in the correct way. And which way is my airflow? My airflow is this way. So the new fan is going to sit in like this. So I'm going to mount the rubber feet on here. And then mount the fan in place. It fits in exactly like the other one did. This one's got a little more, another part of a bracket to it, but I think we're okay. And there's our new fan in place. So when it mounts in the set like this, just making sure my airflow, the airflow is going to come out this way. So the fan spins this direction like this. This is an exhaust fan. So we make sure that we get our fan in the correct direction. Now I need to modify the connector. Now this fan here has got 3 terminals on it. The red is 12 volts, the black is ground, and the yellow is the RPM sensor. Just going to cut the wires off here so that I can splice it onto the 4 wires that are on this one. We're only going to use 3 of them. We don't need to use the blue, which is the speed control. The green is the RPM sensor. The black is the ground. And the yellow is the 12 volt supply. So I'm just going to splice the wires here and put some heat shrink on there, and then we can put this fan back in this set. So I've got 3 pieces of heat shrink tubing. We'll put them over the wires just so that I can insulate them once I'm done here. Now our color code, as I said, is a little different on this because it appears that there's no standard that says that the positive should be red. This is a computer fan, and some computers use the red for the 5 volt rail and the yellow for the 12 volt rail, so they're using a yellow wire here for 12 volts. I would imagine that the red on this is the 12 volts, and the yellow is the speed sensor. So we're going to put our black to black, our yellow to the green, and our red to the yellow. That's the way it's going to get connected here. Let's get my heat gun so I can... Actually, I don't even need that. I can use a match. But what the heck? Heat gun's a little more professional. Okay, now to reattach the fan to the chassis, and it was attached, where was it? It was right here. And reconnect the connector for the fan drive. That wire doesn't matter, that's just a speed wire, so we don't need to worry about that one. Okay, set's all plugged in again, ready to turn it on. And there we go, set's on. Fans are spinning. I got good airflow out of here. TVs are working. There it is. We're gonna let this thing run for a while here and verify everything's good on it. And then we can send this one back on its way. That's the 11 blink problem. It's a bad fan. So here we go. The set's been running now for about 6 hours today. And I ran it for the rest of the night last night. It's been running today for about 6 hours. All is going good. One thing I will recommend is that you don't put in a computer fan like I did, because the voltage from the speed sensor on a computer fan is different than the voltage from the original fan. The original motor uses a Hall effect device, and the levels are lower. The computer fan drives it with a higher level. So in order to keep it stable, I had to, that's the video, that's not the TV cut note. In order to make it stable, I had to make some slight modifications to the circuit, and I'm not going to go into what those modifications are. I'm just telling you, if you have a fan failure like I had on this one, get the right fan for it. I don't know what Panasonic is going to charge for it. A computer fan is less than $10. Computer fan's working fine. Everything's working perfect on the set now. But I did have to do some slight changes to some of the circuits, to some of the resistors on one of the boards. I'll show you the board. So this is the PB board. The 3 fans plug into this board. There's some components on the back side of the board and an IC, and then they provide a signal out this connector that goes back to the main controller. And they're not only measuring the speed of the fans, but it's also measuring the voltage from the yellow lead, which is the yellow lead is the sensing lead from the fan. And a PC fan has a different level than the Panasonic fans. I would think that the Panasonic level is lower. And that was causing some issues. So I did some slight modifications by changing some values of resistors to make the signal compatible from the new fan. Again, I'm not going to tell you what I did to it because I'm not going to encourage people to modify a set. I don't want any liability for it, for anything that might happen. I'm just telling you, if you've got a fan failure like I had on this one, get the correct fan and then you won't have to modify it. So that's all I'm going to go on this one. The set's fixed. It was a fan failure. We diagnosed it. You could hear the noise that the fan motor was making. The 11 blink code is a bad fan. Change the fan, get the right one for it. If you want to put in a PC fan, you can do it, but again, you're on your own as far as modifying that PB board to get the levels correct. It is just a level difference, and I was able to put the scope on it, but again, that's beyond the scope of this video because I'm not going to lead you down any unauthorized modifications. One thing is certain though, these Panasonic 1080p full HD televisions have got to have one of the best pictures I've ever seen. I love them. Thanks for watching, and we will catch you in the next one. Any questions, comments, shoot me an email. Catch you later.